In 1992, a ship lost its cargo, which included 28,000 rubber ducks. Floating around in the water, the ducks did not remain together. Instead, they ended up all over the world and gave us insight in how the hidden ocean currents work. The wind affects and drives the upper layer of the ocean currents. In the northern hemisphere, these surface currents move in a clockwise circulation, whereas in the southern hemisphere, they move anti-clockwise. This is due to the Earth's rotation. Deeper down in the ocean, we find the deep ocean currents, which are not driven by the wind like the surface currents, but instead they are driven by the thermohaline circulation. This is also known as the ocean conveyor belt, since someone thought it looks like a huge conveyor belt. Anyways, thermo refers to temperature and haline to salinity. Both factors affect the density of the water. Cold water is denser, heavier if you like, than warm water. Additionally, salt water is denser than fresh water. This difference in water composition causes water to either sink or to rise in different regions of a planet, which result in these water currents. Thermohaline circulation is a part of a large-scale ocean circulation system, and it's especially strong in the Gulf Stream, which goes from the Gulf of Mexico to Europe. Near the equator, the heating from the sun makes water evaporate. This creates a higher salt concentration that correspondingly causes the water to sink. This process is a continuous repeat and creates a warm current. The turning of the Earth and the west winds leads the Gulf Stream towards Europe. The Gulf Stream is critical for the climate in West Europe. The heat from the warm water is released into the air. This is the end of the Gulf Stream and the start of the North Atlantic Current. In the North Atlantic Current, the water becomes cooler and therefore sinks again, creating the largest underwater waterfall on Earth called chimneys. With a width of 15 kilometers and a dropping of 4 kilometers, the water flows southward in a deep ocean current. Could it really be possible that we humans are affecting a system so great? And if so, then how? One example is the large amount of fresh water being released in the ocean due to a rise in temperature. With melting land ice in places like Greenland, the less dense fresh water is diluting with the heavier saline water of the Gulf Stream, preventing it from sinking and returning to the equator. This could shut down the thermohaline circulation and stop the transport of heat from the equator up to the north, which could then trigger cooling in Europe and affect ecosystems all over the world. Needless to say, not only terrestrial species will be affected. A disruption of the ocean currents could also negatively impact the contribution of oxygen to the deeper parts of the ocean. Without the sinking of cold saline water from the Gulf Stream, oxygen wouldn't be provided to the depths of the sea, leading to the death of many organisms. The climate has always been changing, but since the last ice age, the currents and the winds have stayed rather stable. With climate now changing at a rapid speed due to us humans, it is certain that this complex system of ocean currents and winds will do so accordingly. Actually, two different papers published in Nature 2018 provide evidence that human-induced climate change is already affecting the ocean circulatory system. However, since it's such a complex system, it makes it almost impossible to predict all the consequences. As said before, Europe faces the risk of becoming much cooler if the warm water from the Gulf Stream will come to cease. A weakening in the ocean current circulation is also associated with tropical rainfall shifting southwards and the warming of the Antarctica. Therefore, it's important to slow down our impact on climate change and do something about it today.